In this video, I'd like to give a brief introduction into processes and tools involved in the graphene growth and graphene device fabrication in PTB's cleanroom facility as a part of our work in the Ampere project GIGS, the Graphene Impedance Quantum Standard. We start with a walk through the white area, passing the thermal evaporator on your left that we use to deposit lithographic metal contacts for our graphene devices, and we approach our postdoc Atasi, who is operating the graphene furnace where the graphene is grown on silicon carbide substrate. On the left side of the furnace there is the pyrometer that measures the process temperature in the center of the system, close to the graphene samples. And now you can see me opening the system with the inductive heating system, or the coils that enable rapid heating to the process temperature of up to 1900 degrees Celsius. And we come back to the growth process later in this video. And now we continue in the yellow area where the chips are prepared and also later lithographically fabricated. And here you can see a sequence from the cleaning process of the substrates in an ultrasonic bath using isopropanol and acetone usually. And for enhanced nucleation later, during graphene growth, we then apply a surface treatment to the substrates with polymer adsorbates that are deposited in the sequence by spin-on deposition. Using the pipette. And then the substrates are immediately taken out and to the furnace to initiate the graphene growth process. The system is controlled via a LabVIEW program. The system first needs to be vented with argon gas until ambient pressure is reached. You see the blue curve rising, the pressure, and after venting, the core element that holds the sample, the so-called susceptor, is removed from the system. And then the susceptor is removed. The susceptor itself is a graphite cylinder that can be opened. And then the prepared substrates are carefully placed into the pocket in the center. Then everything is put back. And the system is then evacuated to start the main process. The temperature is then ramped in steps, first to 900 degrees, then to 1200 degrees, 1400 degrees, and up to 1750 degrees. Here in this instance. While the lower temperatures play a role mainly in the growth of the first carbon layer, the graphene forms at the much higher temperature within just about 6 minutes. For characterization of the graphene chips, we use a laser scanning microscope, and such kind of microscopes can provide a very high contrast between the monolayer graphene, bilayer graphene patches, and uncovered areas. And one usually obtains grayscale images, in this case of 32 times 32 micrometers. And in a second you see the typical gray contrast of graphene monolayer. In this image, where the darker spots are small uncovered area, and there was no bilayer visible in this image. So one could then try to optimize the recipe to increase the monolayer coverage if needed. And then if the quality of the graphene sample is satisfying, the device or the chips are further processed using photolithography to deposit contacts and to structure the graphene to finally have the Hall bar. And here you can follow how we use the microscope to characterize a processed graphene quantum Hall device with palladium gold metal contacts. And so you saw how the device looked like after processing in the images before, and these are the contacts, zoomed in images of the contacts with graphene Hall bar region on the right and metal contacts or parts of the metal contacts on the left that are highly reflective and thus appear white in this image.